Mo, and today we're gonna continue with our natural language processing project. And today we are gonna go through vectorizing. I will show you how to apply vectorizing on our text, and then I will describe a little bit about TFID, Vectorizer, one of the vectorizers that you would use when you're doing natural language processing. And then we are gonna go through machine learning model and classification on our Twitter dataset. So here we got this dataset. We had some tweets and labels, and we cleaned this tweet, then we tokenized them, lemmatized them, and then we got a final list, which is like lemmatized text without the stop words. So now we're gonna go through the vectorizer, and I want to use TF-IDF vectorizer. So I already imported this library TF-IDF vectorizer from scikit-learn, which is one of the top libraries in Python to that you can use in NLP and a lot of other projects. So first we want to, we have this here text, different types of words in a list, and to use it in our TF-IDF vectorizer, we should first convert this words in the list into the text like this one that we had at the start. So I'm going to join them, these words together, and I'm going to say, okay, call it final text, and I'm going to read it from final list, right? And I'm going to apply lambda. It's just simply joining them within a space. So I join every word there within a space, and yes, I think that's it. So at the end I want to see data frame. So cool. We got this final text here, and this is this is the whole the sentence. Maybe it doesn't look like a sentence because we removed a lot of words, but yeah, this is the joint version of the final list we have here. Now we can apply it on our vectorizer. So first I want to talk about this term frequency, inverse document frequency, and what does it mean. You already know that we're working with text, and computer doesn't understand text. So to make computer understand it, we should convert it to digits and numbers, and this is how we are going to do this. And we are vectorizing in words inside the text. So here I prepared a file that shows how we can calculate this, and actually this process is happening behind the library that I already imported. So if you are not interested, you can skip this part, but this is the logic behind the whole process, so maybe you're interested. So the TF-IDF has two different things. First is the term frequency, and second one is IDF, inverse document frequency. What does it mean? So term frequency means number of times a term appears in document. So let's say we have 3 sentences here, right? And each sentence has a different number of different words. I have a dog, I have a dog. And second one has also different words. She has a dog and a cat. So here she has, so A, we had it here, dog and cat. A also we had it before, right? So this is how we can split the text into the word and to say, okay, what words do we have in each text. So we can calculate the TF by, it's very simple, number of words in we have 4 number of words in this sentence, right? So simply it's appears once in this sentence, right? I, yeah. So I can say I will like just divide 1 to 4. That's it. Sorry. And have a dog, they also appear 1, so they all have like same like percentage, right? For the next one, it's also like we can calculate it like this, but here a appears 2 times, right? A and A again, but the rest of them appear just like once, and the other ones are also all the words that are happening one time. So this is how we can calculate TF, like tone frequency. And the second one is IDF. It's a little bit more complicated, but I think it's also like easy to understand here because I have an example. So number of sentences in like the whole corpus that we have here is 3, right? We have 3 sentences. So I is like happening one of them, right? So we can like divide 3 to 1. So because we have 3 sentences and in one of them we can see I. We can use the same formula to calculate all of this. So have is also happening once, but A is happening 2 times, right? So it's like 3, you can divide 3 to 2. So it's 1.5. Dog is also like A, but the rest of them are like happening only once. That's right. And then we calculate their logarithm, like logarithm of this, and they like calculate like this, and this is the number that we can get. So to calculate TF-IDF, we just need to multiply them. So we multiply this 0.48 to 0.25, and that's the number that we can get for each sentence. We had different word, and for each word we have different TF-IDF, and that's how we can calculate it. So here we can just use the whole like library and let it calculate it for us. So I already imported this TF-IDF vectorizer, and I'm gonna call this like Vectorizer, and I'm gonna say TF-IDF Vectorizer, and then I'm gonna feed it to my data frame and like the data set that I have here, and I'm gonna choose this final text, right? Because this is what we have got so far. df dot final text. That's it. And then I can call the result x, and the result would be actually the same row. And sorry, and instead of it we can transform. Same thing. You can also use, like, there is a fit transform function here. You can also use that, but just to clarify the steps, I did in 3 steps. So we can run it, and yeah, everything is done here. So yeah, we have got our vectors here, and I'm gonna call y, and y is the labels that we already have, right? So data frame dot label. That's it. So I have x, I have y. But first the machine learning part, and we need to split train and test dataset. So we train the model on train dataset and then test it on test dataset. So for this reason, I am using train test split from scikit-learn library, and let me just make it faster. I already have this, and you can search for train test split, and you will find this, right? So and here let's call it y. So we can split our x into x train and y train, and our y to x train and x test, and our y to y train and y test. And this is how we can do this, and you can choose whatever you want. I think 20% is enough for this model here. So I got the test and train data sets, and that's okay. So I'm gonna go for Random Forest Classifier, and also imported this Random Forest Classifier from scikit-learn. And this is just like the other steps that we had before. So I'm gonna call the result classified text. Classified. Okay, start with classified text, and it's gonna be, let me see, yeah, it's gonna be Random Forest Classifier, and then I'm gonna fit it to, so we have X train here and Y train. So I'm telling the model that use X train and Y train to train you yourself, right? It might take some time, so I'm gonna pause it and show you the result at the end. We have got our model, and now we trained it, and let's see how does it work and like if it's like accurate or not. So I'm gonna define predictions, and I'm gonna refer to this one and then use predict. And so we want to predict our like the result or the label of our test data set. So it's gonna be X test, right? And yeah, let's run it. Sorry, it's it's X test. Okay, and we want to calculate it, and now we got this, and let's use like this accuracy score from scikit-learn to see the accuracy of this prediction. Okay, so I'm gonna just copy this accuracy score, and I want to compare this accuracy of, sorry, predictions and let's say Y test, right? So it's the label that is already there, Y test, and that's gonna be it. Oh, cool. So you can see that we got more than 96% of accuracy. So our model can predict the labels in more than 96% of the time, which is perfect. And so we also can use this confusion matrix and classification reports from scikit-learn. I'm gonna try to show the result here. I'm gonna print it. So let's go first for confusion matrix. So this matrix can use Y test and prediction. Okay, and let's see, confusion matrix. I had to add this example. That's really easy to understand. So this says that, okay, the actual value is 1. So here is like 1 is the hate speech. This is just an example, right? And the predict value is also 1 in this case. So it's the true positive result. And it says that, okay, we predicted that it will be 1, and in reality it's also 1. So we have like almost 6,000 items that we predict right, okay? And here it's like false negative. So we say it's, for example, the actual value was like they're all hate speech, but we falsely predicted them as non-hate speech. And here we have like false positive. So we say it's not, let's say it's not hate speech, but our model predict them as a hate speech. So that's one of the others. And true negative, that it's not a hate speech and our model classifies them as not hate speech. So that's how we can interpret this. And next one, we're gonna go to classification reports, and we're gonna print it. Classification report, and I'm gonna go for whitest, and also predictions. So say here we can see our precision, recall, F1 score, and support, and this is our labels, like for like label 0, which is not hate speech, and I would say most of the labels were 0, non-hate speech. And we have like 97% precision, 100% recall, 98% F1 score, and these are the number of items that were like 0 labeled. This is the like definition of 1, which is hate speech. In 92% precision was correct, in 49% recall was correct, and you can see the other numbers. And yeah, that's all about this like data set and model that we got and the result that we have here. This is one like simple natural language processing model, and I hope you enjoyed it. Please like and subscribe my channel and videos. Thank you.